Hello, I will continue from the last video. Next topic is the tasks. C++11 provides another way of calling the function asynchronously using async library. It is said to provide more abstraction than using thread library because it uses future promise object pair to get the result of async execution. That is a more straightforward and abstractive way of communication channel between caller and callee threads. Of course, the future promise object can be generally used for the thread communication without a sync function. Promise object is first declared and the future object is obtained by calling get future method, and then the thread function has a promise object pointer as parameter to set the value, which will be provided to the main thread being called by calling get method of future object. However, we have to understand the default policy of a sync library that may cause unexpected hanging of your program. What is that situation? Async have two policies as default. First is async, and the second is deferred. Which is chosen? It depends on the current system's load. Scott Myers said in the situation of not being able to create a new thread, async library choose a default option to avoid system error exception. When I simply tested async in my laptop, it's always performed as async option in normal situation. But in the situation of overload, having no resource to create a new thread, async library will execute your function with default option, which means your function is called synchronously in the same thread of caller when the caller invoke get method. Yeah, it means that your function will be executed exactly at the point of calling the get method of in caller thread. In this situation, a wait for method of a future object should not be used because it doesn't suspend caller thread. Thereby, a function called by async with the default option could be hanging forever because it waits for the caller thread to suspend by calling wait or get method. So, if you want to use wait for, you should not use the default option. Instead, use async option explicitly to ensure your function executed on different thread. Okay, the next condition variable. This is the most important topic in this video. What's the purpose of condition variable? It gives a way of awaiting suspended thread. This kind of communication between thread to thread or single thread to multiple threads by calling count variable wait method to enter the suspended state and calling the count variables notify or notify all method to awake suspended thread. This mechanism is very useful in solving the producer-consumer problem. Let's see the next code. Producer pushes items into the queue named goose, and the consumer pops items at this code. The consumer is using while loop to check if the queue is not empty, even though the consumer is not pushing items. The consumer doing while loop is consuming the CPU clocks. That's why we have to use condition variable not to waste the CPU power. Let's solve the producer-consumer problem step by step. I ran this code without changing. The provider thread pushes items, increasing the counter, and the consumer thread pops items, decreasing counter. So the count value in the end it should be 0, and as you can see, the result is not correct and even not consistent in multiple execution. What's the problem? We can imagine the race condition happens in the code. Push pop operation of Q and the increase and decrease counter value also were in a race condition. We can simply add the lock variable to ask mutex to set this operation as a critical section like this. Thereby, we got the correct answer. In this code, I reduced the range of lock area to extract more performance. I got a smaller execution time, but this code is very small, and just pushing and pop the operation is not enough to measure performance. And the next code is increasing the number of consumers up to 3. This means that 3 consumer threads are doing pop and decrease operation at the same time, but as you can see, my program is aborted. I guess the issue is that the empty and the pop operation performed at the same time. So I moved the lock position to include the empty operation. But this code lock area totally covers the while loop, so this will make other consumer threads suspended while just one thread does pop operation repeatedly until the queue is empty. So finally, I modified the consumer code like this by reducing lock area, but still covering the empty operation to avoid abortion. And actually, do something function normally should be located here out of lock area, because popped items could be handled independently with other items. So multiple consumer threads can execute do something function at the same time with better performance in multi-core platform. Okay, that's it. Thank you for watching.